How the Arduino string class causes memory leaks and also memory defragmentation. Using strings in a programming environment where no garbage collector is provided can quickly saturate memory. I assume that you understand the basics of C and C++ programming and understand the concepts of variable pointer, memory addressing, and pointer arithmetic. For many programmers, the string class is the devil, but actually, if you take a look at the code, you can see that it does what any C and C++ programmer would do. Let's get to the point. The string class, summarizing very quickly, does nothing more than use malloc to allocate a buffer of characters in the heap, and then release them when it exits the scope of a function by mechanism of disposition or in the structure method. However, there is a problem with this procedure. The continual building and destroying of string buffers in the heap creates a number of blocks in memory that, even if freed by a free instruction, still remain unused. In a computer, this problem is solved by using processing such as defragmentation or virtual memory. Therefore, creating an instance of type string in a method means creating a buffer of characters in the heap and releasing it when exits, generating a series of holes in the memory. So, how best to use the Arduino string? The smart thing to do is to allocate a string class as a global variable so that the buffer created in the heap is reused several times without being destroyed. However, this creates a problem. If you use a very long string only once, the buffer will remain the size unnecessarily occupying memory. This, however, will not be a bad thing, because if necessary, it is possible to manually call a destructor method of the string class and free the occupied block of memory, which in this case would be which in this case would be big, always better than a series of small blocks. In this case, in this example, I use the string class and assign a literal string to the variable. And doing this operation, the compiler will create a buffer using the malloc function of the length of bytes equal to the length of the string entered. This operation is done within the scope of the function. This operation is done within the scope of the function in which the string is inserted. When the scope is left, when we get out from it, the string class destructors will be called and the buffers created in the heap will be freed. So, more strings are inserted into the scope, more buffers will be created in the heap, and consequently, more holes left in the heap. This is therefore recommended, as said above before, create a single string class as a global variable and then eventually free the buffer created by calling the class's destructor function directly, manually. Okay? Like this. If you don't want to use string because you don't like it, or like me, who use fake it for testing, you don't want to use non-standard C++ library, you can use malloc. by using it as a global variable and resizing it with realloc or freeing it with free eventually when it gets too big. It is necessary at this point to distinguish between the two most common cases that arise when programming a microcontroller. The first case is characterized by the presence of dozens of strings used for displays or for AT commands, such as SIM modules or Bluetooth devices. We are therefore talking about constant literal strings that do not change during execution. The second case occurs when it is necessary to receive response strings, which are therefore dynamic during the execution of the program. In the first case, what is the best strategy for not wasting memory by using tons of strings in programs that use SIM modules or Bluetooth device or display? The best practice is as follows. Using program to create a precompiled string containing all strings separated by null character. It is of course possible to create multiple program const char for different contexts. For example, for LCD display commands. Here there is an example of string. I splitted the literal string, and among strings I inserted a comment with relative index. Then a function that returns the size of a searched string. I declared an array, and a function that receives the buffer strings by reference, its length, and the index of string to be retrieved. In this way, for example, it will be possible to create a function that can send AT commands. In the second case, in this case, we're talking about a string that we don't know how long it can be, such as the serial string, the serial read string function. So as said before, we can use a buffer in the heap with malloc or realloc, or continue with the buffer array in the stack. However, what the first and the second cases have in common is that we are always able to know the length of the string first, and therefore it will be possible to cite an array in the stack or a pointer in the heap. To know the length of the string and decide the array or heap pointer before executing a serial read string, you can use serial available and avoid to use string. Unfortunately, it is always used in this way rather than. So then the function called can receive my array by reference with the right length and the length, obviously. Loads the array and this function can load the array with the serial read, avoiding the use of string class, because you can put every characters in the array properly resized. This is what to do if we are dealing with devices such as SIM or Bluetooth. Obviously, if communication is between microcontrollers, or custom solutions, And an initial serial call will have to be made, which will require the number of characters to be loaded into memory. You can make a call before, forget the number of characters that you need to store in your array. Okay?